In this video I'll be completing solutions from the intermediate tier paper made from legacy materials, first set in November 2014. This is the paper 1, no calculator. For any students not from Bryn Hafren school, these papers have been made from legacy materials, and if you download the foundation and higher paper for November 2014 on the old spec, you'll access the questions. Question 1 is on formulae. It says the formula for the cost of hiring a skip is given below. Cost of hire equals number of days times £40 plus a delivery charge. When you see a formula like this, they're not going to remind you about bidmas, so I suggest you add your own brackets around the things that are being multiplied together to remind you that would need to be done first. What we then do is rewrite out the formula, but replacing any words with the value if we provided it to substitute it in. So this question says Jack hired a skip for 5 days and the cost was £250. What was the delivery charge? Now I'm not going to write cost of hire, I'm going to write 250 equals bracket number of days, which is 5, times 40 close bracket plus the delivery. Now that's good because that's the only thing now that I don't know, which of course is what I've got to find out. So I've got 250 equals 5 times 40 is 200 plus the delivery, which I'll now just call D. Hopefully you can see then that the delivery must be £50, being the difference between 200 and 250. On another occasion, Jack hired a skip for £350, so cost £350, and the delivery charge was £30. For how many days did he hire the skip? So now this is days times 40 plus 30 for the delivery charge. Now if we take the delivery charge off the 350, we're left with £320. So 320 must represent the daily charge without the delivery fee. So we got days times 40, 320. How many 40s go into 320? Link 4 and 32 in your multiples of 4, and you should see that the days then equals 8, because 8 40s make 320. Question 2 is on area and perimeter. 3 identical rectangles, each measuring 7 by 3, are placed together to make the shape shown in the diagram. So all 3 of these rectangles are congruent. So I'm going to write a 7 there to start things off, a 7 there, and a 7 there, because I know that the entire length of the rectangle is 7. And because I know the height or width of it is 3 there, I know that that's 3, I know that that's 3, and I know that that's 3. Now perimeter involves working your way around the entire outside of the shape, and what that gives me a little problem here at the moment now, because I've got a component length I don't know the full length of. Now if this bottom bit is 3, this horizontal length here, and the whole length is 7, then the difference is 4. So because 3 and 4 add up to 7, this length is also 3. 3 and 4 make 7. I wouldn't recommend writing 3 there, because you might confuse it when you come to add a perimeter, because we're only interested in the outside. In a similar way, this length here is also 4 as well, because 4 add 3 add up to 7. I suggest now for perimeter, put in a little point to remind yourselves where you started, because we're going to go around the shape now, adding up lengths. So I'm going to come down this way, 3 and then 7 first. 3 plus 7 plus 3 plus 7 brings me up here, plus 4 plus 3 plus 7 plus 3 plus 4 plus 7, and I'm back to the start. Examiner will give us a mark for seeing the number 4, as they'll be pleased we calculated that length. We're also going to get another mark because we've evidenced we understand perimeter, and if I can add these up correctly, then I'm going to get my third mark. 3 and 7 is 10, add 3, add 7 is 20, add 4 is 24, This takes me up to 34, 37, altogether 48 centimetres. Then says calculate the area of the shape. Write down the units of your answer. Now because we got centimetres on our length, I'm going to write centimetres squared down straight away to get myself a mark. What I need to do now is evidence that I understand that area of a rectangle is width times length, the two sides times together. So like this rectangle here on its own, width times length or length times width would be 7 times 3, which is 21. Now this is one of the easier questions because the rectangles are side by side, there's no overlap. So because that's 21, so is that, and so is that at the top. So we can then say 21 times 3 is 63, and it's 63 centimetres squared. Question 3. We've got a line segment running from P to Q, and below a couple of questions about the line segment. Write down the coordinates of the point P. Should be a nice easy one to start off with. Start at the origin and remember then that we go along the corridor before we go up the stairs. So across to -3 and then up 1. So the coordinates of P are -3, 1. The point R lies on the line PQ. The y coordinate of R is 4. What is the x coordinate of R? So on this line somewhere there's another coordinate that has the y coordinate 4. So I need to go up 4 to be on that line. And then if I just move my pen across, we can see that that's there, because that is where the y coordinate is 4. And the x coordinate there is 3. So I'm looking at 3, and it's because the point 3, 4 lies on the line. At the bottom, the coordinates of the point 1, 3 add up to 4. 1 add 3 is 4. Write down the coordinates of the point on PQ, which add up to 1. Now if I start at the top here with Q, that's the coordinate 5, 5. They add up to make 10. That's way too big. The one we just worked with, 3, 4, they add up to 7. That's too big as well. This point here is 1, 3. That adds up to 4. That's too big. And then when I work my way down here then into the negative, I've got -1 and 2. Now if I think about what -1 plus 2 is, start at -1 on your number line, add 2 on, move 2 places to the right, and you get 1. So it is that one there, -1, 2. Three children share 20 cubes. Melanie takes 25% of the cubes. John and Denise share the rest of the cubes. John gets more cubes than Denise. So I've got this grid here to help me. The question is, what's the greatest number of cubes that Denise could get? Now start things off. 25% of 20 is a little bit of maths that I can do there. I'm going to use the half it and half it again method to know then that Melanie takes 5 cubes. So I'm going to write M across there in those 5 boxes. I've then got 15 left. Now all it says in the third line is John and Denise share the rest of the cubes. John gets more cubes than Denise. So if there's 15 left, like as an example, John could get 12 and Denise could get 3. Alright, he's just got to get more cubes and they've got to add up to 15. But we're trying to see what's the most cubes that Denise could get. So ideally what we'd be looking for is that John perhaps only gets 1 more than Denise. But a good way to do this now would be to share them out equally to start with, because we want her to be as close to John as we can. JD, JD, JD. We go again, JD, JD, JD. And then we're only left with 3 squares. So if I do another JD, at the moment they've got 7 each. There's 7 J's and 7 D's. So if I pop another J in there then, John's got 1 more. So John gets 8 and Denise will get 7. And that's where we were looking. 8 and 7 do add up to 15. Gail buys 8 biros for £3. 3 of them are black, the others are red. So if there's 3 black, I know that there's 5 red. Each red biro costs 45p. What is the cost of 1 black biro? Well, if we start things off knowing that I've bought 5 reds and each red costs 45p, 5 times 45, partition 45 is the quickest way to do this. We can see then that's 225p, which is £2.25. Now, if Gail has spent £3 altogether, £3 minus £2.25 is 75p. You can always use a column subtraction there if you're unable to do that in your head. So 75p is for the other black biros, which are for 3 biros, and 75 divided by 3 is 25p for a black biro. Next question is simplify. I've got 4x minus 2y, which I'll leave out for a moment, minus 3x. Just remember to circle the sign with the term as well. Whatever sign is in front is the one we're interested in. So the first little sum I can do is 4x take away 3x, which is 1x. Then I'm left with minus 2y plus 5y. So that's obviously something y. Minus 2, start at minus 2 on the number line, plus 5 is moved to the right. If you move 5 spaces to the right, you'll end up at 3. So it's 3y. Put these two together then, x and 3y, and because they're both positive, it's a plus in the middle. Simple 2-step equation next. I want to get t equals a number on its own. So the first thing I can do is add 6 to both sides, because that'll eliminate that minus 6 then. So 5t equals 15, and now I can divide by 5. So t equals 3. Find the value of 2p and 5q when p equals minus 3 and q equals 2. So 2p is 2 times minus 3, which would be minus 6, because of course a positive and a negative multiply to make a negative. And then 5q is 5 times 2, which is 10. And there's a nice plus sign in the middle of that. So I've got to do minus 6 plus 10. Start at minus 6 on the number line, move 10 spaces to the right, and you'll end up at 4. The sketch shows a triangular plot of land with a church marked C, a school marked S, and a bus stop marked B. The actual straight line distances between these places are also shown on the diagram. So we've got not a scale drawing, 200 meters, 250 meters, and 300 meters making a triangle. Very important information here. Using a scale of 1 centimeter to represent 25 meters, construct a scale drawing of the plot of land. So we've got to draw a triangle without a triangle and using a compass, make a construction. Keyword there, construct. Okay. Got all my kit ready. That's what we're looking for here, folks. We need a ruler and a compass. Now, we've got 1 centimeter equals 25 meters. So what should jump out of this here is this length, 250 meters. It's pretty straightforward to see that that would have to be 10 centimeters, because 25's just got an extra 0 on the end, which is times by 10. So 10 25's make 250. Then that's essentially what we're doing, is seeing how many 25's go into these so that we can work out what it is in centimeters. There are 8 25's in 200 meters, so that's going to need to be 8. And of course there's 12 25's make 300, so that's going to be 12 centimeters. We start out, I'm going to do some of this in pen so that it stands out nicely on the video, but you should always use pencil in the exam. We're going to draw the longest line first, which is 12 centimeters, and take the ruler away, and I'm just going to write 12 centimeters there. Now we've got to use the compass twice. They'll be looking for some construction marks. I'm going to draw this length next, an 8 centimeter line that's connected to this point S. Now the way that we're going to do that is, if I open my compass to be exactly 8 centimeters, like so, like that, we can move our line around, because obviously the 8 centimeters needed to join the left hand side. I can put my compass point on the end of the line, and then I can make a nice swooping arc, like so. So this arc is all the points that are 8 centimeters away then from this end. If I take my compass again and set it to be the other length, which was 10 centimeters, like so, I can put my compass down on this point, come back the other way, and I've made a cross, an intersection, and that is what the examiner is looking for, because this point right here is the point that is exactly 8 centimeters away from here and 10 centimeters away from here. So we can join them up like this, and I'm just going to write 8 centimeters there and 10 centimeters there. Do not rub out these lines, they are your workings marks. We've got a probability question next. In a game, a player rolls a coin onto a board marked out in squares. The squares on the board are coloured red, blue or green. If the coin lands entirely within one of these coloured squares, the player wins a prize, otherwise the player loses. The table below shows the probabilities of the coin landing entirely within each coloured square. Now these are given to us as decimals today. Very common for the WJC to use fractions, but a decimal probability is fine, because 0.13 is 13%, which is also 13 out of 100. So you can use any one of those variations that you like, really. Blue is 14%, which is 14 out of 100. And green is 0.04, which is 4%, or 4 out of 100. Now the probability a player wins a prize, it was if it landed on any of these. And 13 and 14 and 4 comes to 31. So we can present our answer as 0.31 or 31% or 31 out of 100, whatever you prefer. One day 200 people play the game. How many people would you expect to win a prize? Well, if I take my answer there, 31 out of 100, that means if 100 people played the game, we'd expect 31 to win. So if I'm looking for 200 people playing the game, I know that's double. And double 31 is 62. So 62 out of the 200 would win. But I can't leave that, and that is a fraction, and they've asked how many people, so I am just going to write 62 people next to that to make sure I get my second mark. They will not be happy if you leave your answer like that. It costs 70p to play the game once. The prize for winning is £1.50. If the 200 people play the game once, how much profit do you expect the game to make? Essentially 200 people are going to give you 70p each. Now 2 sevens are 14, and add on the 3 noughts we left off, you're going to get 14,000 pence, which of course is £140. So £140 is going to come in to your business. Now you're going to be paying out prize money of £1.50 to an estimated 62 people. So we got to give 62 people £1.50. Smartest way really to do this is either to partition the money, £1.50, which I'll talk about in a minute. The foolproof way is to just multiply 62 times 15. Because of course if we ignore the decimal point from £1.50, we've got the digits 1, 5 next to each other. So that's 600, 300, 20 and 10, and that all adds up to 930. Okay, now if we think about it, we left off a 0. If we were going to turn that into pence and make it 150, we left off a 0, so we can add that 0 back in there, and that's not 9,300 pounds, that's still pence, so it's £93 out. The difference in between those two then with a takeaway is £47 profit. Because we were dealing with £1.50, if you think of that as being a gold pound coin and a silver 50p piece, if you had 62 of the pound coins, that would give you £62. And if you had 62 50p's, well, there's two 50p's in a pound, so you can just half 62 to get 31. So you'd have £62 from the £1, £31 from the 50p's, and they would add together to make £93. But there's nothing wrong with showing full workings there if you're more confident. ABCD is a parallelogram with ADC equals 46, the angle at D 46, and ACB 59, the angle A 59. Find the size of the angle X. Now in a parallelogram, your Z, F and C rules apply. Alternate angles for Z, corresponding angles for F, those angles are the same, and in a C shape you end up with your supplementary angles adding to 180 degrees. Now because of the Z and properties of a parallelogram, we also have that opposite angles are the same. So if that's 46 down here, then this is also 46 up in the top corner. And then we don't really need to use a Z rule or anything like that because we've now got, of course, a 180 degree triangle in this top part of the parallelogram. So we can add 46 and 59 together to get 105. And if I subtract 105 then away from 180, I'll be left with 75 degrees. At the bottom, find the size of angle Y. Two quite simple rules just combined into one problem. Your four-sided shape, your quadrilateral, has 360 degrees in it, and because we've extended one of these lines here along the bottom, it's made a straight line which we know adds up to 180 degrees. If I find out what this angle in here is first by doing 180 take away 125, that comes to 55 degrees. So 55 degrees is the angle inside the quadrilateral there, the interior angle. And then I've got three angles inside the shape, 117, 141 and 55. I can add all of these together to get 313. And so my missing angle Y, the last one in there, is whatever tops up 313 to become 360. And 360 take away 313 comes to 47 degrees. Following is part of a train timetable from Bangor to Chester. We're given three possible trains that we could get on, running between sort of mid-morning and early afternoon. There are three separate trains that leave Bangor at these times. That doesn't mean you have to get on the train at Bangor, of course, because the Bangor train will call at all of these stations on the way to Chester. So if you've got, if you live in Colwyn Bay and want to go to Flint, you can get on these trains at 11:31, 12:46 or 13:31. First question says, Bob catches the 11:31 train from Colwyn Bay when would that train arrive at Prestatyn? Well, the 11:31 is the first train that we're given here. So when will that train arrive at Prestatyn? It'll arrive at 11:47. No need to put AM because the whole timetable is given in 24-hour clock. Mary catches the 13:25 train at Llandudno Junction. How long should it take her to get to Chester? So the 13:25 from Llandudno Junction is this one, the third train of the day, and then she's going all the way down to Chester at 14:19. Now we got to find the difference, and the temptation is to do 14:19 take away 13:25 in a column, lining up hundreds, tens, units, etc. But that will not work. If you try it yourself now, you'll come up with a really weird answer, and it doesn't work because of course hours use 60, not hundreds. So when we're borrowing our tens and hundreds, etc., we're not taking into account the fact that hours are 60 minutes long. So the best way to find differences between times, I think, is to add in really easy increments. I know I've got to go from 13:25 to 14:19, and I'm going to start by just adding myself 5 minutes to take me up to 1:30, and then I'm going to add 30 minutes to take me up to 2 o'clock, and then I'm going to add 19 minutes to take me up to 14:19. And so my answer then is 5 add 30 add 19, which is 54 minutes. Express 240 as a product of prime numbers in index form. This is the fancy way of saying factor-trees. So we start off with our 240, and because it ends in a 0, we could do 10 times 24 to start off with. As long as the two numbers below multiply to make the number above, we're absolutely fine. You can pick anything. 2 times 120. Product, of course, means times, so that's what's happening here. Now 10 is 2 times 5, and 24 is 4 times 6. Remember, I can pick any multiplication that I want to. And when I come into this row and I look at 2, the only thing that makes 2 is 2 times 1. And if I added that on, I could go on forever, and there's no point because these are prime numbers. This was our objective. So I'm going to circle 2, and I'm also going to circle 5 because they're prime. 4 and 6 are not prime, so I'm going to go down another level. 2 and 2, like so. And I'm going to make a deliberate mistake now on 6 because I see it so often. The temptation is to put 3 and 3. But that's not right. Okay, people slip into 3 plus 3 is 6. This would need to be 2 as well, so that 2 times 3 makes the 6 above, and then they can be circled. So 240 equals 1, 2, 3, 4 2s times 3 times 5. And in index form, that's 2 to the power 4, because there's 4 of them, times 3 times 5. The diagram shows the transformation of triangle A to triangle B. Fully describe a possible transformation of triangle A to triangle B. Now there are 2 answers for this. You should know your 4 transformations are translation, enlargement, rotation and reflection. Now my first thought would be that this is a reflection. So what I want to do first is jot on where the mirror line is. Now I can see it there because there's 2 squares between the base of both triangles to get to the mirror line. Now I'm going to start off by writing reflection because that gets me 1 mark. But what I've got to do as well is put the equation of the mirror line. Now because it's a horizontal line, this equation is very easy. We follow the line across until we find that it cuts an axis, and it cuts the axis here at 1. So it's something equals 1. and that something is the axis that it cuts, y equals 1. Because the line runs through y equals 1, that is the equation of the line. Reflection in y equals 1. If we were looking at an x equals line, I'll just draw one on here just for you to have a look at. This line here would be x equals 6 because it's running through the x-axis where 6 is. So that's one of them, reflection in the line y equals 1. Or you may see that it could be a rotation. If I mark an x there, if I was going to do the tracing paper swivel, which I'll do in a moment, this is also a 180 rotation. So I could put that if I chose, rotation 180 degrees. We don't need to say the direction because of course 180 you end up in the same place whether you go clockwise or anti-clockwise. But what we do need to say is where we would put our pivot point, obviously right in the middle of this, and we call that the centre, and you've got to give a coordinate now of where that x is, and that is at -4, 1. So you'll have a mark for the word at the top, reflection or rotation, and another mark then for your specific line or centre. And it says rotate triangle A through 90 degree clockwise about the origin. Label your answer C. And the origin, we should never forget, is 0, 0. Fancy way of saying 0, 0. So I'm going to get my tracing paper over the top. If you have, this is kitchen paper, baking paper. If you don't have any tracing paper at home, and we trace on our shape as A. And what we do now is at 90 degree clockwise. I'm going to put my pen down on there to act as a pivot so that I can actually physically move my tracing paper into position. And he ends up there. After I've done a quarter turn, which is 90, just ends up like so. And then very carefully we pick away and we draw in with a ruler, of course, where our new shape ends up, and they said label it C, so it's there. A nice question here. Draw an enlargement of the shape below using a scale factor of 2. It's only worth 2 marks. Normally these are worth 3 marks because they give you a centre as well. In my other videos you notice we've been using the centre, but this is literally just double everything, double every side, and it can be drawn anywhere because they haven't given us a centre. So because this length is 2, my new length is going to be 4 to start things off, and this length here is 1, so my new length is going to be 2 across, and that'll be a mark there for drawing in the vertical and horizontal lines. It's the diagonals that are a bit of a problem, and it can be a bit of an issue. What we need to do, we need to get that point in exactly the right place. And what I want you to do is have a look at this shape here and notice that to get from this corner to this corner, I need to go down 2 and I need to come across 3. Alright, that's going to give me the right slope for the diagonal. So if I do that over here now, go down 2 and then across 3, but of course because I'm scale factor 2 I've got to do that again, down 2 and across 3, and it basically puts my pointy bit there where I've marked the little O. So I can pop him in there like so, and then of course I can just join these up like that, and then there is my full enlargement doubled. Sophie is going on holiday. Sophie travels a distance of 35 miles in 2 hours 30 minutes through busy traffic. Calculate Sophie's average speed in miles per hour. Now I know people would be tempted at this point to draw your SDT triangle, speed equals distance over time, but you'd have to remember that 2 hours 30 minutes would need to be put into your equation as 2.5 hours, It's not 2.3 or 2.30, it's 2.5, 2.5. So because we're calculating speed, that's distance divided by time, we'd have to divide by 2.5, which perhaps isn't easiest. So I want to show you a different way. Speed is all hypothetical. What if you went this in this time? How fast are you going? The information we're given for sure, though, is that on average she's done 35 miles in 2.5 hours. I'm actually going to use a bit of proportion here to say, well, if she carried on at that pace, she'd be going 70 miles in 5 hours. Okay, I'm going to go again, I'm going to double again. So if she carried on, she'd be going 140 miles in 10 hours. And what I've got now, because I'm looking for miles per hour, is a really simple division by 10 to know that I effectively would be going 14 miles in 1 hour. And that's exactly what speed is, 14 miles per hour. Sophie's luggage weighs 22 pounds. Approximately how much does her luggage weigh in kilograms? There are 3 metric imperial conversions that you definitely need to know going into the exam. The first one is that 5 miles equals 8 kilometers. The second one is that 1 litre equals 1.75 pints. And then there's the one that's going to help us out here, that 1 kilogram, a bag of sugar, is 2.2 pounds. Now the fact they've given us 22 is quite nice, because obviously 2.2 times 10 makes 22 pounds, so it's going to be 10 kilograms. Sophie is due to fly from Glasgow to San Francisco. She arrives at Glasgow Airport on Wednesday at 1:40. I'm going to write that down. Arrive airport at 13:40. She has to wait 4 hours 25 minutes for her flight. So her flight is going to leave Glasgow 4 hours 25 after 13:40. Now 13:40 plus 4 hours is 17:40. And of course add on then the 25 minutes will actually take us over to 18:05. So her flight is going to leave at 18:05. It takes 13 hours to fly between Glasgow and San Francisco. I realise as well I should be writing Wednesday next to these times, because it does talk about dates as well in a moment of when we actually arrived. So it takes 13 hours to fly between Glasgow and San Francisco. So I need now flight time is 13 hours. So I need to add 13 onto this. So if I think about this now, it's 6:05 in the evening. If I added another 6 hours out of this 13 on, alright, plus 6, that would take me to 0:05, 5 after midnight. And the day will have gone to Thursday. And if I add the other 7 hours on, that'll take me to 7:05 on the Thursday. What I did there is just split the 13 into 6 and 7 to make it easier to add in 2 little chunks. So it's actually gone over to the next day, or at least she feels it has, because she's still on British time there. To her it feels now like it's breakfast time. She's gone through the night. But this bit here now, she knows that the time in Glasgow is 8 hours ahead of the time in San Francisco. For example, when it's 10 a.m. in Glasgow, it is 2 a.m. in San Francisco, so they're behind us. So when we're in school having lessons, it's early hours of the morning for them. They're yet to catch us up. So what we've got to do now is adjust the time and take 8 hours back off. Now if I knocked off the 7 hours, that would take me back to 0:05, still on Thursday. And if I take off another 1, something really bizarre happens. It goes back to 23:05, and it would still be Wednesday. So even though she feels like it's a Thursday, because there's such a big time difference between San Francisco and Glasgow, she's actually landing in America still on Wednesday, only just. The diagram shows a rectangle ABCD. Given that XB is 2.5, DC equals 12, I can see those both marked on, and the area of triangle ADC is 60 centimeters squared. That's not marked on, so I'm going to put it on there. I'm just going to do that just so I know that that's 60. Calculate the area of triangle XBC. It wants me to work out this angle in here, area in here. Now then, two triangles there, and if I'm talking about area, then I need to be doing base times height divided by 2. Okay. Over here now I've got 2.5, which is great, but I really need to know the height of BC so that I can just times those two together and then half. Now I can't do that unless I use the information over here they've given me. I need to know what this is. Of course, because it's a rectangle, it's the same as that. So I'm going to work over here first, which is going to give me the information I need for thereafter. So 12 times something, then divided by 2, makes 60. That's what I'm looking at. Or the something, the height, times 12, and then divided by 2 equals 60. If I use my reverse operations to get back to there, 60 times 2 and then divide by 12 is going to give me the height. Now 60 times 2 is 120, and 120 divided by 12 is 10. So the height is 10 centimeters. You can check it. 10 times 12 is 120, half it makes 60. So now this is 10 over here as well, 10 centimeters. So the area of this triangle is 2.5 times 10, all divided by 2. 2.5 times 10 is 25. So 25 divided by 2, that's 12.5 centimeters squared. A bit of algebra on this page now. Solve 3x divided by 4 equals 36. Even though it looks complicated with the fraction, if you remember your inverse operations, you'll be fine. I want to rid myself of that divide by 4 to start with, and the inverse of divide by 4 is to multiply by 4. So I know then that I'll just be left with 3x equals whatever 4 times 36 is. So I'm not going to take any risks. I'm going to make sure I get it right. 120 and 24 add to 144. And likewise now I just need to divide by 3, and I don't want to be trying to do that in an exam either without use of the bus stop. 3 into 14 goes 4 with 2 remainder, and 3 into 24 goes 8. So 1x is 48. Solve 9 over x equals 18. 9 divided by x equals 18. Now we see these in our trigonometry when we end up with our hypotenuse, when we're trying to find our hypotenuse mainly. X goes down into the denominator and we know what the answer is, and we call it a swapper because we need x to be in the numerator. And for that to happen, because we're dividing and multiplying, we can switch these two around. So 9 over 18 is what x is. That's absolutely fine as a solution, you have done it, but just recognise that 9 over 18 does simplify to a half. And we got 5x minus 12 equals 3 brackets x plus 6. We'll take a mark to start with for multiplying out our bracket on the right hand side. 3 times x is 3x and 3 times 6 is 18. And now this is a 3-step equation. My ultimate goal is to get x equals a number. So I don't like 3x being there, and I don't like minus 12 being there. So I'm going to take 3x off first, because then this side will just drop down to 18, which is nice. Nothing's happened with the minus 12, that stays exactly as it is. But because I'm reducing by 3x, I've got to keep balance and do the same on both sides. 5x take 3x is going to give me 2x. So 2x minus 12 equals 18. Now I'll add 12 onto both sides. So 2x equals 30. And then I divide by 2, and x equals 15. Solve the inequality 9x plus 5 less than 77. If you've got the skills from the previous page, you can do these as well. We follow exactly the same idea, reverse operations until we get x on its own. So I'll take off 5 to start with, take off 5, so 9x is less than 72, and then divide by 9, so x is less than 8. Basically all we're doing, rather than finding the one solution that works when we have an equals there, we're finding the range of solutions that work for this. So any number smaller than 8 will work. If I pick say 3 for example, because 3 is smaller than 8, 9 3s are 27, plus 5 is 32, and yeah, 32 is smaller than 77. If I pick a number bigger than 8, like 10, 9 times 10 is 90, plus 5 is 95, and that's not bigger than 77. So numbers smaller than 8, the first one being 7, is where this would start working. Write down the smallest whole number that satisfies the inequality 4x bigger than 45. Now 45 divided by 4 could be done with a bus stop, but if you ever think about it, we could do a little bit of trial and error. If x equals 10, we're looking at 40 being bigger than 45, because 4 10s are 40, and that's not true. 40 isn't bigger than 45. If x equals 11, then 4 11s are 44. So is 44 bigger than 45? So no. But when we step up then to x equals 12, 4 12s are 48, and 48 bigger than 45 is a yes. So x equals 12 is the smallest whole number that works. Then we've got to simplify all with multiplication. So I've got my numbers to start with. 10 times 5 times 2 is 100. And then there's an x there, an x there, and an x there. So effectively it's 100 x. But we know that that's poor form to write it like that. We should be saying x cubed. The question we saw in our mock, just ever so slightly different. The product of 3 consecutive prime numbers is 385. Find the sum of these 3 prime numbers. I have said you must know your prime numbers going into the exam. So we've got 2, 3, 5, we've got 7, 11, 13 and 17. That's plenty. Product means times, so we're going to multiply. So I need to find the 3 consecutive numbers that multiply to make 385. I'm going to take a guess at maybe like 357. 7 5s are 35. Times 3 is 105. That's a bit too small. Not too far away though. So I'm going to try these next. 5, 7 and 11. 11 7s are 77. And 77 times 5. If I partition, I get 385, which is what I was looking for. So my 3 numbers are 5, 7 and 11, and they wanted the sum of these numbers. So 5 plus 7 plus 11 all adds together to make 22. Then we got factorize a quadratic, x squared minus 10x plus 16. And hence solve the equation. Remember the solve bit is the easy mark on the end. It's the 2 marks of factorising that are harder. I need two brackets like so with an x at the beginning of both. So it might be like x plus something, x minus something, but it's got to give me 16 on the end and minus 10x in my middle term. Now if I use the grid, because we use our grid to expand, I got x there and x there, and x squared in there, and I need now, zoom in a bit for you, I need 16 to be in this bottom right box. I can't just pick two random numbers that multiply to make 16, because I know that these two terms then need to combine to give me minus 10. So if I try 16, is 16 times 1. I know that 16 is 8 times 2, and I know that 16 is 4 times 4. I'm looking at how I would make 10 out of these factor pairs, and it makes me look at the 8 2's, because 8 plus 2 is 10. So I'm going to put 2 there and 8 there, and that's 2x in there and 8x in there. Now I'm not quite done, unfortunately, because of this guy here, this minus. I need to make minus 10x, and I make minus 10x by having minus 2x and minus 8x. They both need to be minus. So these both need to be minus as well. And of course then you'd think, oh, does that affect the 16? But it doesn't, because the product of two negatives is a positive. So my answer now is x minus 2, x minus 8. That gets me 2 marks. The solve bit is simple. Just take the bracket and write x equals and take the sign off the number, because we're looking at equals 0. So 2 take away 2 is 0, and that's what we're looking for. And in this one then, we won't put minus 8, we'll put x equals positive 8. The table shows some of the values of y equals 3x squared plus 2 for values of x from minus 2 to 2. Complete the table by finding the values of y when x is minus 2 and x is 2. Now normally I suggest you plot the 3 points they give you first, so that we can kind of estimate where these coordinates will be, because they'll have to lie on the line. But unfortunately here we haven't been given any scale on our graph paper. It's easy to see that we'll do this because they've picked the x coordinates for us, so that's fine. But how much should I be going up, and in what scale should I go up in? So I am going to have to calculate my coordinates first. So I'm going to put 2 in to 3x squared plus 2. So that's 3 times 2 squared plus 2. Remember your BIDMAS now. 2 squared is 4 times 3 is 12. So that's 12 plus 2, which is 14. So 2, 14. And I'll do the minus coordinate, the negative. I got 3x squared plus 2. And now I'm doing 3 times minus 2 squared plus 2. This is a bit bizarre, because we still do our power first, but minus 2 squared is positive 4. So I still end up with 12 overall. 12 plus 2 is also 14. Now if you look here, we got a bit of symmetry in our coordinate, 14, 5, 2, 5, 14. So we're going to get a little bit of a mirror image. Now I need to go all the way up to 14 on my axes, and a quick count, you see they've given us 7 boxes. So if I go up in 2's, I get all the way to 14 at the top, and then I can just plot my points. Minus 2, 14, minus 1, 5, 0, 2, 1, 5, and 2, 14. Like that, and we get that nice U shape. And I've then got to connect all my points with a curve, not with a ruler, because this will give me a nice curvy parabola shape. That's what we're looking for there. I'll just zoom out a bit. Okay. Question 16. A fair dice is thrown twice. The score is noted each time the dice is thrown. Calculate the probability of getting at least 1 6. Now I think the easiest thing to do on this is to draw up a little sample space table, because two things are happening and we want to see all the different possibilities we could get. So a sample space diagram would be a big square with all the things filled in, and off the first dice we are 1, 2, 3, 4, 5, 6, and on the second dice 1, 2, 3, 4, 5, 6, like so. And now if we are looking the probability again at least 1, 6, I'm just going to think, right, what would I be looking for? Well, I wouldn't be interested in that because that's 1, 1, and I wouldn't be interested in that because that's 2, 1, 3, 1, no, 4, 1, 5, 1, not interested. But when I get down the bottom, I would be interested in that because it's got a 6 in it. And I said probability again at least 1, 6. And that pattern's going to continue all the way across the bottom. And especially here where we get double 6. Now likewise, if I start thinking about this row, 1, 1's no good, 1, 2's no good, 1, 3, 1, 4, 1, 5 all no good, but 1, 6 is good. Likewise 2, 6 would be good, and 3, 6 would be good, and 4, 6 would be good, and 5, 6 would be good. So altogether I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 chances of getting at least 1, 6 out of the 36 different numbers or outcomes that would be in this sample space. Carwin has bought a 10-sided dice, and we can presume then that it's got the numbers 1 to 10 on it. Carwin was not sure if the dice was fair. That means does one number come up more often than the others. He carried out an experiment. He recorded the number of 6s he threw in every 10 throws of the dice. So he threw it 10 times and he got 4 6s. Now given that these dice have all the numbers 1 to 10, that does seem a little high, or a little bit of a freak occurrence that could happen. On the second throw then he got 3 6s, and then 2 6s, 3 6s, 2 6s. Perhaps these 6s are coming up a little more than we'd expect them to. But what he's done now, he's done a little bit of a cumulative effect to see if he can work out the probability. So this first column's no problem at all, because he did 10 throws, he got 4 6s, so that's 4 out of 10, which is 0.4. In the second column though, this number's gone up to 20, because what he's done is say, but after I'd done my 2 trials, which add up to 20, I had 7 altogether, so I've had 7 out of 20, and he said that that's 0.35, and he's done that by making 20 into 100. That's times by 5, and 7 times 5 is 35, so that's where he's getting these from. Then he added on the next 10, which made 30, and another 2, 4 and 3 and 2 makes 9, and so on. He's going along, adding on another 10, and then the number of 6s from that 10 onto this. So we'll continue that now. He got 20 there, another 10 throws took us to 80, and he got 4 6s, so that goes up to 24. Then another 3 takes us up to 27, and another 2 takes us up to 29. So our fractional probabilities are 24 out of 80, 27 out of 90, and 29 out of 100. That's easy there, that's 0.29. These other ones not so easy though. 24 over 80. Now 80 doesn't go into 100 directly, so I'm going to simplify it first and go to 12 over 40, and simplify again to 6 over 20, and simplify again to 3 over 10, and then I can see, yeah, of course that's 0.3 or 30%. Do the same on the other one. 27 over 90, now it can't be halved, but it could be divided by 3, and we get 9 over 30, and it could be divided by 3 again for 3 over 10, and that's also 0.3. So these two are equivalent fractions. In fact, there's a good few equivalent fractions, because we get 0.3 a few times. We've obviously completed Carwin's table opposite, and now we've got to draw a graph to illustrate the relative frequency of throwing a 6 on Carwin's 10-sided dice. So we're all set up here. All I'm going to be doing now is for 10, 20, 30, 40, I'm going to be plotting this bottom row of decimals. So my first one is after 10 throws was 0.4, which is all the way up there. 20 throws then was 0.35. Then it was 0.3 twice for 30 and 40. Goes to 0.28 for 50. Now check your scale. 0.3 is the same as 0.30, and 0.2 is the same as 0.20. There's 10 little squares in there, so it means it goes 0.21 and so on up to 0.29 just below there. So one square is 0.01, and that makes the next bit a little bit easier because I just dropped 2 squares now for 50 for 0.28, back up to 0.3 for 60, drop 1 to 0.5